today we're going to be drawing inferences from data. So we're going to start out by reading a book, What's the Point of Math? It's kind of a history book. It's going to show y'all where this all came from. Then we're going to go over what sampling is. We're going to practice a few questions. We're going to discuss them, and then we're going to do a little mini exit ticket. Then we'll be done for the day. So today, by the end of the lesson, you're going to be able to understand how to identify a population versus a sample. You're going to be able to determine if the sample is a good representation of a population, and then you're going to use a sample to make quantitative population inferences. Alright, so we're going to read a book called What's the Point of Math? And like I said, this is giving just kind of a history on what we're learning today and how it all came about. So, how to estimate the population. How do you work out the population of a country when it's impossible to count every single person? This question puzzled French mathematician Pierre Simons Laplace, who in 1783 wondered if he could use math to accurately estimate the population of France. He came up with a brilliant solution that combined smart logic with some surprisingly simple arithmetic. So the person who came up with this whole idea was Pierre Simon Laplace. So he did the math, and he realized that he could estimate the total population by finding out how many adults there were for each baby born. Although most towns didn't keep record of their entire population, there were some that did, and he used these to make some calculations. The relationship between two quantities is known as a ratio. We use a colon to separate the pieces of information. A sample refers to a portion of the population. It is used to represent the population in a study. There are a couple techniques to sample, but a sample must represent the entire population and it must not be biased. Who can tell me what bias means?
Picking them over and not picking certain people.
Picking certain people, right. It means that all members have an equal chance of being selected. So, this is why choosing the appropriate technique from the list below is important, and there's 4 of them. Convenience, simple random, stratification, and systematic. Has anyone ever heard of those terms before, or are they all new to you? We kinda heard of them before, maybe a couple of them, maybe 1 or 2. Alright, so sampling techniques. If every person figure on the screen is equal to 10 students and the sample size must be 60, inspect how each technique can be used. So, which one out of these 2 would y'all choose? The simple random?
Yes.
Why?
Because it's very random and everyone has an equal chance.
Everyone has an equal chance? I like that answer. Good job. It's time to practice, so we're going to do a couple problems together, and then we're going to do one on our own and then discuss it. So let's all turn, I think it's page 77 in our book. Number 2, on this one we're not doing clustering. So what we just did on that one, we're going to use all the dots on the dot plot. Alright, the following dot plots show the amount of time it takes each random sampled student to complete 2 different sets of math homework problems. What is the mean time for each set of problems? Who can tell me what mean means?
Basically, add all the numbers and divide it by how many there is.
That's perfect. Add all the numbers and divide how many there are. Okay, so let's do set 1 first. So, how many 27s are there? 2. So then what's 27 plus 27? Y'all can use your calculator, it's okay. 54, perfect. How many 28s are there?
2.
What's 28 plus 28? 56, perfect. How many 29s are there?
3.
What's 29 times 3?
87.
87. How many 30s are there?
2.
What's 30 plus 30?
60.
Are there any more dots on the plot?
Yes, 32.
Good job. All right. Now add them all together. Someone give me an answer. Mm-hmm.
It equals 29.
29. All right, but how'd you get that?
I added 54 plus 56 plus 87 plus 60 plus 33. Now I divided by 5.
What was the answer to adding all these up?
290.
290. And then you divided by what number?
5. Wait. 10.
By 10. Why'd you divide by 10?
Because there's 10 dots.
Because there's 10 dots. Perfect. And then he got 29. Does everyone get that? Mm-hmm. All right. So let's do set 2. I want everyone to try this one on their own. If you get your answer, just go ahead and put your pencil and calculator down. Don't forget to write it on your paper though. Someone give me the answer.
25.
25? How'd you get that?
I times 24 by 4.
24 by 4? Okay.
And then 25 times 4.
Okay.
And then 27 times 2. And
Okay.
then added them up and then divide by how many dots there were.
Perfect. Sounds great to me. Does everyone understand that one? Okay. So, make a comparative inference based on the mean values. So set blank of homework problems is more challenging than set blank. So each problem in set 1 takes about 29 minutes. Each problem in set 2 takes about 25 minutes. So which set do we think is more challenging?
Set 1.
Set 1. So which one's easier?
Set 2.
Set 2. Perfect. All right. Y'all go ahead and try number 3 on your own. And then we'll discuss it. If y'all finish early, you can discuss it with your partner. Let's go over this. Sonia randomly surveys 26 7th graders to gather data about the amount of time spent each week using the internet. Sonia reports the data in the dot plot shown. Sonia infers, on average, most 7th graders use the internet a little more than 7 hours each week. The mean of Sonia's data is blank hours. We said the mean is the average, right?
Mm-hmm.
All right. So what did we get for this answer?
7.5.
7.5. Did someone get anything different? It's okay if you did. No? Okay. How do we get a 7.5? Can someone explain that to me?
So what you do is you add all the dots up and all the numbers up as well, and then you divide both of them.
Add all the dots up and all the numbers up, and then divide by how many dots there are. How many dots are there?
26.
Did you have to count it, or did it show you somewhere in the problem?
It shows you somewhere.
Showed you somewhere in the problem, right? Right up here. All right. So the median of Sonia's data is blank hours. What does median mean?
The
middle.
The middle. What did y'all get for this one?
7.5.
7.5. How'd y'all get that?
Because whenever because you count up all the dots and you find the middle, and since the 13th dot is at 7 and the 14th dot is at 8, you find what's in the middle of 7 and 8,
Mm-hmm.
and you get 7.5.
Did someone do a different method? What was your method?
I crossed out each dot until I got to the middle.
You crossed out each dot. Let's show. That's my favorite method. I'm going to show everyone that one. It's real easy to me. Just sitting here, crossing out. Make sure not to get confused by what numbers you're crossing out. 7 plus 8 is what?
15.
15. 15 divided by 2 is what?
7.5.
7.5. Alright, do the measures of center support Sonia's inference that most 7th graders use the internet a little more than 7 hours each week? Explain why. What'd you put?
Yes, because the median is 7.5, so they get around 30 more minutes.
Perfect. Yes, because the mean so they get around 30 more minutes. Did anyone say something different, or do we all agree? We all agree? Awesome. Just write one thing on the sticky note that you learned today, or maybe what did you get refreshed on that you already knew? Someone raise their hand. What's one thing you learned today?
How to find the median.
How to find the median? That's awesome.
How to find the median and mean with dot plots.
How to find the median and mean with dot plots. All right. Thank y'all so much for participating today. I had a lot of fun. And that's all I have for you.